Hey Trig class, this is our lesson on section 4.4. We're going to be looking at graphing secant and cosecant functions. So far we've learned sine, cosine, tangent, cotangent. So these are the last two trig functions that we are going to be graphing. And then one thing I do want to say is that the graphing techniques for this you will see that they correspond very much to their reciprocal functions, cosine and sine. Okay, so let's take a look at them. Okay, so this is our secant function. The domain for it is this right here stated. It's kind of hard to say into words, but that is our domain. The reason that we have x not equal to this is because, again, like in tangent and cotangent functions, we have vertical asymptotes, so places where our x values do not exist. And then the range for this function, notice if you're looking at the graph of this, uh, there are no there is no point in the graph where it goes between -1 and 1. So the only portion that you actually see graphed on this function is from 1 to infinity and also -1 to -infinity. So that is why we have this range right here. Okay, another thing about this function, just looking at the graph, remember how I told you periodic functions are the way we determine a period is uh, after the point in which it starts repeating itself is how you determine where your period begins and where it ends and what one full period is of your function. So we can see this right here is one portion of our function, and then here's another portion of our function, and then it starts repeating itself over and over and over again. So if you go on your graphing calculator and take a look at it, you would see you would get this repeating pattern, uh, this little U up here and then upside down one down here and then back up and then back down and back up, and it keeps on going in that pattern. Okay, but if you notice after you see one full period right here after 2 pi. There, from, let's say, from here to here, if you were to add up those values on this x value from this distance from here to here, we would get the distance of 2 pi. Okay, so let's take another look at some properties of this function, like this right here. So like I said before, we have vertical asymptotes. So it has discontinuities on this graph at these x values. And then there are no x-intercepts. We notice that in the graph also. There aren't any points in which it crosses the x-axis. And then its period is 2 pi, just like their reciprocal functions, sine and cosine. Secant and cosecant are going to have a period of 2 pi also. These graphs of these functions are going to have no amplitude since there is no minimum or maximum values. Just like our tangent and cotangent functions, there was no min or max. And then the graph is symmetric with respect to the y-axis. So this function is an even function, meaning if we look at our function here that is graphed, this line right here, the y-axis, is our mirroring line. This is where it reflects across, and you can see that whatever is on this side of our graph is the same if we were to flip it to the other side of the graph. That's what it means to be an even function. It's reflective across the y-axis. Okay. All right, so for the cosecant function, it has many of the same properties as we looked before. Just like the sine and cosine function, they look very much like each other. The secant and cosecant graphs are going to look a lot like each other. So here's where the domain for this function is going to have their vertical asymptotes. And then the range for it, again, is the same thing as the secant function. And notice, again, for this one, you can see that it has the same shape. It's a portion of it's up here, and then a portion of it's down here. Then again, it's going to repeat itself up and then down. So the portion that repeats itself over and over from 0 to 2 pi, that is one full period, 2 pi. Okay, so again, here's some properties of the, sorry guys, this is supposed to say cosecant, not cotangent. Let's write that up there. Cosecant of x. But the graph is discontinuous at these values, as we stated before. So these are the vertical asymptotes. Again, no x-intercepts. The period is 2 pi. Has no amplitude. And the graph is symmetric with respect to the origin. So the function is known as an odd function. Okay, let's look at another property of these functions. Okay. Another thing about sine and cosine graphs, comparing them to the cosecant and secant graphs, you can actually graph these two functions, the reciprocal functions, together on a graph, and you will notice some identifying properties about these two graphs when you graph them together. So let's look at that. Okay, so here is a sine and a cosecant graph graphed together. Okay, so here's our sine graph, this wavy pattern right here. And then here's our cosecant graph along with it. Okay, notice this, that wherever my x values, my x-intercepts are on my sine graph is where the vertical asymptotes are going to lie. So every time your sine graph crosses the x-axis, that is where your vertical asymptotes are going to lie. So it's how I'm going to show you how to graph cosecant functions is graph your sine function, and then from there, use that information to help you in graphing your cosecant function. So, and also at this point right here, they will have the same value, 1, and then here, -1. Okay, and then same thing goes with cosine graphs. Here's our cosine graph right here. And then our secant graph is what you see with these U's and upside down ones being graphed. But again, wherever it crosses the x-axis, so these x-intercepts are our vertical asymptotes for our secant function. Okay, so let's take a look at an example of graphing these. But before we get to graphing these, let's go over a little bit of guidelines to being able to sketch these graphs of cosecant and secant functions. So here is a way that you can do these graphs is by step 1, graph the corresponding reciprocal function as a guide using a dashed curve, and then sketch the vertical asymptotes. And like I said, the vertical asymptotes, if you sketch in your reciprocal functions sine and cosine, well, sine and cosine, wherever those graphs cross the x-axis, so they're x-intercepts, that's where your reciprocal function, secant and cosecant, are going to have their vertical asymptotes. And then Step 3, sketch the graph of the desired function by drawing the typical U-shaped branches between the asymptotes. In this first example, it says graph y equals 3 secant of 2x. Well, this secant function right here, the reciprocal function is cosine. And in the first step, if we go back here, it says graph the corresponding reciprocal function as a guide. And the corresponding reciprocal function of secant is cosecant. And this right here is a mistake. I'm going to write in a cosine of bx. Okay, so treat this as y equals 3 cosine of 2x and graph that function first. So find its period. These two functions are going to actually have the same period. So period of this function is the same as the cosine function. It's found the same way too. So 2 pi over b. And our value b is 2. So that means our period here is pi. And now break that period up into 4 equal parts. So from 0 to pi, you're going to see 0. Now 1/4 of pi is pi over 4. And then 1/2 of pi is pi over 2. And then 3/4 of pi is 3 pi over 4. And then 1 pi. So that's what you're going to break your intervals up into. You can just start here if you want with the first x value after 0. And then pi over 2, 3 pi over 4, and pi. And then graph what the cosine function would look like. So at 0, we would have 3. And then here at pi over 4, it would be 0. Sorry, cannot graph this. There. And then at pi over 2, it'd be -3. And then at 3 pi over 4, be back at 0. And then at pi, be back up here at 3. Okay, so connect them. And you know I'm not good at connecting on screen, so hold on. Okay, so there it is, graphed for 1 full period. But I'm going to continue this pattern. So it's going to be back down here, and then down here, up, and it's going to come up here. Okay, and now for our secant function, we need to use this graphed cosine function as a guide to help us in graphing our secant function. And how we do that is every x-intercept of our cosine function is going to be a vertical asymptote for the secant function. Okay, so all right, so in a different color, I'm going to graph it. Here at this x-intercept, that is going to be a vertical asymptote for our function. And here again at this one, this x-intercept, another vertical asymptote. And here, this one. And it keeps going. For every x-intercept that you have graphed, that is another vertical asymptote. Okay, So that's this. We're graphing more than one period here. Well, a little more than one period. All right, so now how we are going to graph the rest of this function, other than the asymptotes that we have here now, and using this as a guide, we're going to graph the U shapes, the U that are upright and then upside down. So from here, if we have a peak right here, so our maximum, if we have a maximum, this is the way our U-shaped is going to look. And it's going to get closer and closer to that asymptote that we have. And then if we have a minimum, then this is one of our values actually on our graphed function. And on this side, it gets closer to that asymptote. Doesn't cross it, just like tangent functions do not cross their asymptotes. Okay, and then up here, use that. Okay, it's supposed to be getting closer. There we go. And then last one I'm going to draw is this one right here. All right, so as we go down, we want to make it look like it's getting closer and closer to the x value. I cannot draw very well on this tablet, as you'll know, and I'm getting better though. So this is how you would graph this secant function, and this is how you would also graph your cosecant functions. And just use your sine graph as a guide to help you in graphing each of these. Okay, let's look at another one. All right, on this one, we have a cosecant function. So I'm going to graph the reciprocal function, sine. Just as you see it here, I am going to graph y equals 1/2 sine of x plus pi over 4. Because then we can use this function here, just like we did in the last one, as a guide to help us in graphing the cosecant function. Okay, so just like we find the x values that we want to plot against with their y values, let's just start out with the period of this function. And that equals 2 pi over b, 2 pi over 1, because 1's in front of our x, so 2 pi is our period. And then split your period up into 4 equal parts, starting with 0. And the next is pi over 2, pi, 3 pi over 2, and 2 pi. If you do not know how I got these 4 values, or these 5 values here, you need to go back and see the sine and cosine functions that we have previously studied. Okay, now we have a phase shift. So our phase shift is this right here. Let's go ahead and solve for that. What we're going to be adding to each one of these x values here. So x equals, x plus pi over 4 equals 0. So this is what we're going to add to each of our x values is negative pi over 4. And when we do that, this is what we're going to get. We're going to get negative pi over 4, then pi over 4, then 3 pi over 4, and 5 pi over 4, and it's going to keep going like that. You see how we have 1 pi over 4, 3 pi over 4, 5 pi over 4. The next one going to be another odd number in the numerator, 7 pi over 4. It's going to keep having that same pattern. Okay. I know I just stated more than these x values. That stops at, let's see, 0 pi. Yeah, stops here. Okay, so let's graph those 5 points on our graph. So these are x values that we have. Let's do a table and find the y values. Okay, and corresponding y values that we are going to plot on our graph are these right here. So negative pi over 4 gives us 0, and pi over 4 is 1/2, and then 3 pi over 4, 0, and then 5 pi over 4 is -1, and then 7 pi over 4, that gets 0. So let's go ahead and graph these corresponding values on our graph. All right, so this is how I'm going to label my x-axis here. This is going to be my pi over 4. This is 2 pi over 4, so we're going to go split it. All of these little tick marks that you see on my x-axis right here, that is going by fourths each time. So pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, like that right there. And 2 pi over 4 reduces to pi over 2, sorry. But we don't have to write every single value down. So this right here is 3 pi over 4. I was just explaining, so you know why I'm skipping this. It's because the next x value is 3 pi over 4, and this is not 3 pi over 4 right here. 5 pi over 4, and 7 pi over 4. And now we can plot our points. So, let's graph this, or plot this x value here to negative pi over 4. All right, negative pi over 4 is right here at 0. And then pi over 4, I'm going to treat this as 1/2 right here. And then back here at our x-axis. And then down here. And then back up. And there you go. So I'm just going to draw the corresponding sine wave here. Okay, so there's our sine wave. And now use this as a guide, which we could have used just those points there that we just plotted as a guide. X-intercepts, that's going to give us a vertical asymptote for our cosecant function. So that's what we're doing right now, is graphing the cosecant function against the sine function that we just graphed. Okay, so there's the first vertical asymptote. Here's the next one. And the next one. And then now you just want to draw the rest of your U shapes in their corresponding areas they go in. So here we have a maximum, so our U shape goes upward, and here's a minimum, so our U shape goes downward. So there's the first U shape. Let me see if I can draw the next one. Okay, getting closer to the X value here. All right, so there is the other half. It's this way. All right. So there is one full period of our cosecant function. Let's look at another example. In this example, we are asked to determine the equation for this graph that we have here. And if you compare it back to what we have looked at previously on what secant and cosecant graphs look like, let's go back to that page. So on this page right here, here is a cosecant graph, and here is a secant graph that you can see. See how the secant graphs, if there are no vertical or phase shifts acting on it, then this is the type of graph that you're going to have. You're going to have that U shape going through the x-axis at its minimum point, okay? And then on the cosecant graph, you're going to have that y-axis. There's nothing going through it. That is actually one of your vertical asymptotes. Okay, so that's how you can tell the difference between cosecant and secant is vertical asymptote is on the y-axis for cosecant. Your function goes through the y-axis at its minimum. Okay. All right, so since there are no vertical shifts on this and there are no phase shifts, our function is going to have this form here. Y equals a secant of bx. So we need to determine what is a and what is b. And a comes from what would be our amplitude in a cosine function, but here it's our minimum and maximum values on our U shapes that we graph. So this minimum value right here is 1, and this maximum is -1. So a would be 1 for this function. And then our b, how we determine that is from its period. Okay, what we see here, one full period is being graphed here. And this distance right here is 2 pi. This distance right here is 2 pi. Add those together. 2 pi plus 2 pi, that's 4 pi. That is one full period. So in our, how we find our period of our function, period equals 2 pi over b. Plug in your period here, 2 pi, no, or sorry, 4 pi. And then that equals 2 pi over b. Solve for b. So b is equal to 2 pi over 4 pi. When you're solving for b and it's in the denominator like this, a quick and easy way is just switch these values. And that's how you can solve for b. And now simplify. And this gives you b is equal to, pi's cancel out, and you get 2 over 4, which is 1/2. So our function for this graph right here is going to look like this, except our value of a is 1, which we don't need to state that. It's understood. Secant of 1/2 x. And we are done. So there's our function. Here is our last example that we're going to be doing in this lesson, and it's a lot like our last one. And what we're going to do in it, exactly like the last one, determine this equation for this graph. And how we're going to do that is one way, compare it to what the secant and cosecant graphs look like. And if you do that, the comparison back will lead you to that this right here is a cosecant graph. So it's going to have this form here. And then also another thing about this graph is, well, it has an x-intercept. And cosecant and secant graphs of this form right here do not have x-intercepts. So there must be a vertical shift acting on this function that has moved it down to make it where it is touching that x-axis. And how you determine what your vertical shift is this way right here. You want to take all your maximum and minimum values are going to have all the same y value. So you take the y value from your minimum and the y value from your maximums, and you average the two of them. So the y value here is 0, and the y value here is -2. So add them together, divide by 2, and what you get is -1. So this right here is your vertical shift, okay? So on this function, we're going to add or subtract, and subtract 1 from it. We can either put it on the end here, or like you've seen in class, put it before. Let's do that. So -1 plus a cosecant of bx. Now let's find our a and our b value. Okay, so if we have a vertical shift that has shifted everything down to this -1 here, it's terrible. Then our value for a here is going to be, again, it's going to be the average of our values here. Just like how you find the vertical shift is how you're going to find what your value of a is. But it's going to be the absolute value of this number. So we're going to have y equals -1 plus 1 cosecant of bx, and how we determine our b is find our period of our function. So this right here is half of our period, so pi, and this over here is another half of our period. One full period is this whole function that you see graphed here. And it goes from -pi to pi, so the total distance is pi plus pi, just 2 pi. So whenever you go to find your period of your function, you do this. And you solve for b. Well, find b by plugging in 2 pi over here and solve for b. Again, switch these two values and you get b is equal to 2 pi over 2 pi, which is 1. And so up here, we can plug in 1x, or just x. And there we have it. There is our function that we have graphed. We've determined the equation for it. That's all I have for you, and I will see you all in class. Goodbye, everybody.